So now in this video we are going to compare the insertion sort function with the bubble sort function and the selection sort function. So first of all, let us explain what is this insertion sort function and how this insertion sort can be done. What is the insertion sort? Given an array like this, there are some elements inside the array. Elements are 9, 1, 4, 0, 3 and 7. Now in the insertion sort function, initially we are going to assume that the first data is already sorted. For example, the data number 1, which is 9, that is already sorted, and now we are going to take the data from the unsorted form area. So this data is unsorted, and here after this line the data will be in the sorted format. Okay, so we'll take one data from the unsorted format and we are going to put that data in the sorted format here. Okay, and then we are going to compare these two functions. So initially we'll be taking a variable which is a temporary variable to copy this data 1. Now you are going to compare 1 and 9. If you compare 1 and 9, you can see the data 1 is less than 9, so we are going to move 9 in the next location. So 9 will come here, and then we are going to copy 1 into this index location. After this, the data that we will be having is 1, 9, 4, 0, 3 and 7. Now after doing the first pass, we are going to move it here, this entire this boundary, move it here. Now you can see this data is sorted and this data is unsorted. Again we are going to pick one data from the unsorted format and we are going to put it in the sorted format. To do this, we are going to copy in the temporary variable. So we are going to copy 4 in the temporary variable. Then we are going to compare 4 and 9. Now you can see 4 is less than 9, so we are going to copy 9 here, 9 will come here, and then we are going to compare 4 and 1. So 4 is greater than 1, so we'll copy 4 here. Okay, and then again after this, the data that we'll be having is 1, 4, 9, 0, 3 and 7. Again move the bracket here. Now again take the next element and put it in the temporary variable, compare 0 and 9. So 0 is less than 9, so we are going to move 9 in the next location, 9 will come here, compare 0 and 4. 0 is less than 4, so we are going to copy 4 here, compare 0 and 1. So because 0 is less than 1, so we are going to copy 1 here and compare. Now after this we cannot compare with any other element, so we are going to put 0 here. And this is how you can see the data. Now that data will be having is 0, 1, 4, 9, 3 and 7. Again we'll be moving the dot here, this line here, and again you are going to compare with the element number 3. So we are going to copy 3 in the temporary variable. Now compare 3 and 9. So 9 will come here, compare 3 and 4, 4 will come here, compare 3 and 1, because 3 is greater than 1, so we have to copy 3 here. Okay, after this the data that we will be having is 0, 1, 3, 4, 9 and 7. Now you are going to take this element which is 7. So put 7 in the temporary variable, compare 9 and 7, 9 is greater than, so move 9 here, compare 7 and 4, because 7 is greater than 4, so we cannot move it, so we are going to put 7 here. So you can see the data is now sorted. So how many data elements are there? Total 6 data elements. So how many passes we have done? 1, 2, 3, 4 and 5. Because if there are total n data items, then we will be doing n-1 passes, and because we will be sorting n-1 data items, so obviously then last data item will be sorted automatically. Okay, so let us implement this function here. We will be taking this insertion sort function. I'm going to take integer I and j, and we can make a simple function to swap. So I've already created that function, swap function. I'm just going to copy that function from here. I'm just going to copy that function here. There is a simple swap function. Now simple, I have to run for the first loop, that is n-1 time, for I is equal to 1 and I less than n, and we'll be having I plus plus. Okay, this is the first function, right? So we can take a temporary variable, so we'll be taking a temporary variable. Now here let us see what we have to do step by step. Okay, so you can see every time you have to move back, you have to move back until you cannot find a location which is greater than which is not greater than 0, or the element present in that location is less than that particular element. Okay, so for that purposes we will be moving from the next index location. For example, if we started from the index location 1, we are going to compare with the index location 0. Okay, so for that purposes I am going to write here j is equal to I minus 1. Okay, so then we'll be talking while j is greater than minus 1, correct? That is the termination condition. J should be greater than minus 1. J cannot be greater than j cannot be minus 1. So j should be greater than minus 1, and the element present in that location, and a of j should be greater than the data that we have taken. So the data will be copying in the temporary variable. That temporary variable in the a is equal to a of I. This is the data where we have copied. So this temporary variable is just copying this. You can see in this we have taken temporary variable, so I'm copying the data here. So a of j should be greater than a of I. Okay, or you can say instead of taking a of I, we are just taking the temporary variable, correct? Now if it is done, if this condition is satisfied, then we have to move that element in the next location. So I'm going to write a of j plus 1 is equal to a of j. So I'm just moving that element in the next location. After moving that element in the next location, when we come out of this while loop, we are going to put we have to decrement j minus 1 minus minus. So we have to decrement j every time, and then we are going to put that element in the location where j is stuck. Okay, so we are going to put a of j plus 1 is equal to temp, and this is how you can implement the insertion sort function. So first of all, let us test it if it is working perfectly, if it is correct or not. Okay, so for that we'll be taking temporary variable integer arr with 10 index locations. We'll be taking some values which are 9, 8, 7, 6, 5, 4, 3, 2, 1, and we'll be having last value 0. And again we are going to copy, we are going to perform insertion sort on arr with total 10 index location, and then we are going to print the values for, let's see if it is integer I is equal to 0, I less than 10, and we will be having printf percentage d comma, we'll be having I plus plus. And this is how you can print the values, and let us see if it is working perfectly or not. And you can see it is working perfectly. It is sorting the data fine. That's good. What if the data is same? What if there are some elements which are same? So I'm going to write 4 here, I'm going to write 4 here, I'm going to write 2 here. I have created some data which are same. Now build and run. You can see still, okay, so it is not working perfectly. What's the issue? Let me execute, build and run. 1, 2, 3, 4, 5, 6, 7, 8, 9, and it is not sorting the data in this manner. So let us figure out the issue why it is not sorting the data, rather than it is just printing the data in the random order. Okay, let us first analyze it step by step why it is not working correctly. So we have taken the array which is having the values 2, 8, 4, 6, 5, 4, 4, 2, 1 and 0, and we passed this array inside this. Okay, I understood the value, I understood the problem. So here I have to write a of I plus plus, arr of I plus plus. I'm just printing that value, that's not okay. So just execute. Have I done the same mistake here? Have I done the same mistake here? No, we have not done that same mistake here. Okay, so I'm just going to check it out, build and run again. Now you can see it is working perfectly. So the program was not having any issues, but rather we were just printing the values here I plus plus. We were just doing I plus plus. So it is working perfectly. There's no issues. There's no doubts. Now we are going to use this insertion sort function to find out what is the time taken to perform this insertion sort. So again we are going to copy the same code here, but this time we are going to measure the time for the insertion sort. So Control plus C, we'll be having control plus V, and this time we'll be having, let us sort the data in decreasing order, so 10,000 minus I, and we are going to use insertion sort. After performing the insertion sort will reduce the time taken. So I'm going to build and run. So this time the time taken is 152 milliseconds to perform the insertion sort function. Now what if we implement both the selections, both the select sort and improved bubble sort function, and then we compare the time with the insertion sort function. So I'm going to copy this data here, and I'm going to write it here, and I'm just going to copy these data items from here. So this is for, then here I'm going to copy these data items here, and then improved bubble sort, and then I'm also going to copy it for this is, the data is again 10,000 minus I, and here also it will be 10,000 minus I, and here I'm going to, instead of improved bubble sort, I'm going to call the select sort. So this is select sort, and this time we are going to call the selection sort function, the selection sort with the selection sort function. Okay, so now you can clearly see I've taken an array that is array with the 10,000 elements. I'm storing the data in decreasing order, then I'm implementing this insertion sort function, then I'm printing what is the time taken by the insertion sort function, then again storing the data in decreasing order in the same array, then I'm implementing the improved bubble sort function, and I'm using the time taken by the improved bubble sort function. After this I'm again storing the data in decreasing order, and I'm implementing the selection sort function and finding out the time by the selection sort function and printing out the time. So if you build and run, so you can see okay, so it is saying that by insertion sort function the time taken is 155 milliseconds, by improved bubble sort function the time taken is 314 milliseconds, and by the selection sort function the time taken is 127 milliseconds. Okay, this is the case when the data is sorted in decreasing order. That is the worst case. That is exactly the worst case. What if the data is sorted in increasing order? That is the best case. So in that case I'm just going to remove this one from here. Now the data is sorted in increasing order, or you can say that is the best case. So for the best case, the insertion sort, the time complexity for insertion sort is order of n, that we have already taken. For bubble sort it is also order of n, but for selection sort the time complexity will not change. Selection sort is still going to take order of n square time. Okay, so now you can write down these things here. So if we compare these three algorithms, we have improved bubble sort, then we are going to have selection sort, and then we are going to have the insertion sort, and this is the time complexity in best case, this is the time complexity in worst case, and this is the time complexity in average case. Okay, so for the best improved bubble sort, the best case time complexity is omega of n, so this should be written as omega of n. Worst case is order of n square, and average case is order of n square. For selection sort it is omega of n square, order of n square, and theta of n square. And for insertion sort it is omega of n, order of n square, and theta of n square, that we have already seen in the previous videos in the preliminary course. Now you can see the improved bubble sort and the selection sort both are taking order of omega of n time. Then we have the best case. That is why if we have taken the data in the sorted order here, if you build and run the program, it is taking 0 milliseconds, because that is order of n time. That's one time you are running the loop to find the time to execute the entire improved insertion sort and the improved bubble sort function. But for the selection sort function it is still order of n square. But if the data is sorted in decreasing order, that is it is 10,000 minus I, that is the worst case, 10,000 minus I. Again here we have to do 10,000 minus I, that is the worst case. If you build and run, now you can see the time taken is changing. It is 159, 319, and 128, and you can see that there's not a lot of difference for the selection sort algorithm. Okay, now in the next video we'll be discussing about the time taken by the other algorithms, which are the quick sort algorithm and the merge sort algorithm, or what will be the time taken by quick sort and the merge sort algorithm to sort the data. Okay, I hope this is clear.